This is actually going to lead us into section 4.4, which is on the fundamental theorem of calculus. And so theorem 4.4 basically tells you that continuity implies integrability. So basically it says a function is continuous, that f is integrable. So that basically means you can take the integral of it. And we learned that with like differentiation as well. Okay, so first of all, the definite integral as the area of a region, theorem 4.5. If f is continuous and non-negative on the closed interval, then the area of the region bounded by the graph of f, the x-axis, and the vertical lines x equals a and x equals b is given by this formula. Area equals f of x dx from a to b. Okay, a is less than b, by the way, at least in this example. Okay, so basically what I want you to take from today, when you find a definite integral, so when I say definite integral, what that means is that means you have these limits, and that's what we call those. We call those limits of integration. When you find a definite integral, you are finding the area underneath the curve. Okay, so like with a derivative, you found the slope of the tangent line. With an integral, you're finding the area. Okay, so let's go ahead and look at this. It just says sketch the region. Now today's going to kind of be an intro to it. We'll actually get more to it in section 4.4, which is what we'll cover on Tuesday. Okay, because remember on Monday we've got the Veterans Day program. And so on Tuesday we will cover section 4.4. And so it says sketch the region corresponding to each definite integral. And so now what we're going to be doing is we're just going to be strictly looking at a visual. And so I'm going to go ahead and start with my x and y axis. Oh, I didn't want to use the highlighter. Let's use the pen. Okay. So here's your x, here's your y. And so what I'm going to do now is I'm going to look at the function I'm graphing. And I'm graphing 4. I know that 4 is a horizontal line at 4. Okay? So basically, here's what my horizontal line looks like. Okay? Now this says, what I'm going to do now is I'm going to look at the limits of integration. So notice this says 1 and 3. So I'm going to go to the x-axis. Here's 1. Here's 3. So I'm going to go ahead and draw in my vertical line right here. Oops, I wasn't quite on line with that. Let's try that again. I know. You know what? We'll just do this. There we go. We got it lined up. And there we are. And so it wanted you to sketch the region. This right here is the region that we have. And that's all you do. Okay? So let's look at the next one. This says you want to take the integral of x plus 2 from x equals 0 to x equals 3. So let's go ahead and look at this. X plus 2 is a line. What can you tell me about that line? Okay, be more specific. At 2, at positive 2, it's got a y-intercept. And what can you tell me about the slope? Its slope is 1. So 1 over 1. Going to put me about right here. And then right here. So basically, I end up having that, and this says from 0 to 3 are my limits. So I'm just going to come over here to 3, and there we go. So basically, if I were to integrate that using the fundamental theorem of calculus, which is what we'll learn on Thursday, I would find the area of that trapezoid. That was another way to find the area. But this is actually a little bit easier. Okay? Because you had to learn the background. So then now, 4 minus x squared. Does anybody remember what that's going to look like?
Well, it's going to be 2 minus
x.
Going up.
So real quick, let's look real quick. This would actually be like y equals square root of 4 minus x squared. So how do you undo a square root? You can square, right? So really I have y squared equals 4 minus x squared. Let's move the x squared over, and I really get x squared plus y squared equals 4. What can you tell me about that? What type of graph is that? This is actually a circle. The reason why we know it's a circle is because each of these is 1. It's a circle with radius. Radius 2. Okay? So when it says go from 2 to negative 2, that's actually going to be the endpoints of your circle. Now when it says square root of 4 minus x squared, since it's a positive and not a negative, we know that it's the upper portion of the circle. Okay, and so that's something that you might see again on Thursday. A circle, okay, the numbers in front of the x squared and y squared have to be the same, and then it's going to equal some number. So you could actually have, for this circle, you could have 2x squared plus 2y squared equals 8. And that's still a circle, because you can divide everything through by a 2, and you get the same thing. Okay, so then now the area is going to be this. Why did I go 2? Because this has a radius of 2. Okay. It's a semicircle, yeah. If you would have wanted the full circle, you would have had to have the negative of the square root as well. It would have had to been negative square root of 4 minus x squared. Okay. Alrighty, so now we're going to talk about 2 special definite integrals. And so first of all, it just says if f is defined at x equals a, then we define this to be the case. Now, you don't necessarily need to write down all that other stuff. You can just write the integral from a to a of f of x dx equals 0. Why is that area 0? Or why does that integral equal 0? It's the same number, so basically there's nothing there to take the area of. Right? I mean, it's just, there's nothing to take the area underneath that of. And so that's why that equals 0. Now notice the next one says if f is integrable on a, b, that's a closed interval, then we define the integral from b to a as being negative. Because if you remember, the original definition was a to b. So if I flip those, what I do is negate the value of the integral.
Zero.
Okay, so the first one you already got a 0. This next one is actually real similar to one of the problems we just looked at. We just looked at from 0 to 3 of x plus 2. Okay, and we actually looked at that 2 slides back. So if I go back here, this is the one I'm looking at the bottom here. And if I were to find the area of that, let's go ahead and find the area of that. So to find the area, there's 2 ways. I can find the area of the trapezoid, or I can break this into things that I know. What's the area of this rectangle here? 6. This triangle is going to be, this is 3 by 3. Okay? So it'll be 4.5. Okay? So what would be the area of that triangle, or of that trapezoid? 10.5. So let's go back to this one. What would the area of this be? Negative 10.5.
That's easy, but...
All right. So let's go ahead and last but not least, we're going to look at this. The additive interval property basically says if f is integrable on 3 closed intervals determined by a, b, and c, then basically what they're saying is if c is between a and b, you can split up the integral. So we're going to look at the integral from -1 to 1 of the absolute value of x. Okay. So absolute value is always the shape of what? What is the graph the shape of? Of v. Okay. And so the v in this case is going to be at 0, 0. And then I'm going to go up and up. So really I'm looking at this area right here. And I'm looking from -1 to 1. So what they're saying with the additive interval property, since this isn't like one thing you can take the area of, they're saying let's split it up. And so with that first interval, we're just going to look at this right here. Okay? And if I want to go ahead and look at that, it's going to be the area of -x. Because that's what the graph is. And then the next one will be the area from 0 to 1 of x. Now, let's go ahead and look at that. What is actually the area of this triangle right here, the first one here? 0.5, yeah. Because the base is 1, the height is 1. What's the area of this one? 0.5. So what's the total area? 1. What they're wanting you to understand is that you can break up the integral, and that will help you when we get to the fundamental theorem of calculus in section 4.
What was the negative for then, since we just did nothing negative?
This -x refers to this line right here. This line has a slope of -1, and it has a y-intercept of 0. And so the equation of this line would be -1x plus 0. The equation of this line would be 1x plus 0. And so that's why they correlate with -x and +x. Okay? Alrighty. So now this is what I need you to do in this section. And like I said, we will do 4-4 on Tuesday. On pages 278 and 279, 13 through 28, and 33 through 43. Okay, 13 through 28, 33 through 43.